Agnes Vergara, and today I'm gonna discuss about scientific method with concrete examples. Scientific method is an empirical requiring knowledge of that characterize the development of science since in the 70th century. Method of procedure is characterized the natural science that consisting a systematic observation, a measurement, an experiment, and formulation, testing, and modification hypothesis. And here are the examples and steps. Step 1. Identify the problems. What would you like to know problem are written in a formal question like, does coffee cause cancer? How do I run faster? Do sweet cause acne? How do I memorize faster? Step 2 is research. The research can be a form like looking into internet or talking other people's, reading scientific books, magazines, and Excels. Step 3 is form of hypothesis. It is educated guess. The hypothesis should be based on research or life experience. Step 4 is design it in experiment. The experiment should be designed to test the hypothesis, and during experiment, observation are used to collect measurable depth. The experiment will include 3 variables. The first variable is independent, is a part of experiment that you change. See how the effects the dependent variable is the part of independent variable is always grab x excess. The dependent variable is a part of experiment changes and responds to the independent variable. The dependent variable is always grab only y-axis. And there you have control variable. This variable should be held constant and are used for comparing. There's a large sample size that increases the accuracy of the experiment. The experiment result, many times you need to repeat it, your experiment or several times to ensure against error and may be introduced. Step 5 is results. This is the information that have gathered. Quantitative data is data that is number. Many times is recorded in charts, tables, and graph. Qualitative data is include the illustrations, photographs, and this data that being observed. And finally, the step 6 is the conclusion. And during the conclusion is give us overall results in state whether or you're not may accept or reject your hypothesis, and then describe there is a practicum application. What have you done? And now here is the step 6 scientific method you should know. That's all, and thank you for watching.
Hi, good day. Now I'm going to report the fundamental tenets and the scientific method with examples. So, sources of information, all accepted information can be coming only from careful documentation and controlled observation or experience. Arising from acclaimed postures or prophets or scientists cannot be accepted automatically. They must be validated and proved. For example, for hundreds of years, medicine had a staff in a manual called Materia Medica Galen, a Roman physician who lived in the 2nd century. Phenomena that can be studied study only tangible phenomena and objects such as heat, plants, minerals, and weather. We can see or feel the magnetism neutrons, but we can make detection instrument their reliability. Inversely, We cannot see or smell ghosts, and no instrument can reliably detect ghosts. If for ghosts to exist, they must be invisible and cannot be researched using the scientific method can do anything impossible to study the observed. Constancy and universality allow us to plan future experiments and predict what the result should be. If we experiment and do not get the predicted result, it is our theory that is wrong, not our fundamental strength. The world suddenly changes and prevents people from interpreting things as miracles or perverse intervention spirit. For example, if someone is asking for a new drug cure a specific disease, we can check it with a test the same remedy for this disease. If it does not work, the first person can make an innocent mistake. Second, test the drug on people likely to get it best in any case or commit fraud. Basis for the fundamentals of scientific method is skepticism, the principles of never certainly conclusion, always ready to consider new proof, no matter how much evidence against a theory. It doesn't hurt to be a little skeptical, our thoughts and willingness to examine more evidence. For example, there is a wealth of evidence support the theory that all plants are composed of cells, and there is no known evidence against this. Everything our research, all our teaching assumes the plant consists of cells, but the concept of skepticism requires that if a new conflicting evidence is presented, we must be ready to change our minds.
Give a clear comparison between scientific theory and scientific law. A scientific theory is based on repeated observation and scientific investigation. If new information does not support a scientific theory, the theory will be modified or rejected. A scientific theory attempts to explain why something happens. A scientific theory usually is more complex than a scientific law and might contain well-supported hypotheses. A scientific law are observations of similar events that have been observed repeatedly. If many new observations do not follow the law is rejected. A scientific law states that something will happen. A scientific law usually is based on one well-supported hypothesis that states that something will happen. That's all. Thank you.